Hello, hi everyone. Welcome to the student demand. Hello, hi everyone. Welcome to the student demand. This is Siva sir. Today topic is this is Siva sir. Today topic is electric current. So today we will discuss few more points. Actually, problems also will discuss. Problems also we need to do it. Okay, so let's start. Let's get into the topic. Electric current. Electric current is nothing but the rate of flow of charge. So So electric current I equal to Q by T. I equal to Q by T. So based on this one, so problems, how they will give problems, how to do it, everything we will discuss. So electric current is nothing but the rate of flow of charge. The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay. The flow of charge. So the flow of charge through unit cross section area per second is called electric current. SI unit of electric current is ampere. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. Okay, done. Now, so we'll discuss define SI unit of current. So they will ask about define SI unit of current. SI unit of current we need to define. So SI unit of current is nothing but, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as so 1 coulomb of charge flowing through unit cross section area per second. So that is nothing but 1 ampere. So normally if you are saying here, so this is the conductor, so this is the area of the cross section, Okay. So if the current is passing through it, I am taking this area of the cross section. Okay. So this total length of the conductor. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called 1 ampere. Right? Yes. So I have one question. Will only one electron flows inside of the conductor, will you say current is flowing? Only 2 electrons flows, will you say current is flowing? Only 3 electrons flows, will you say current is flowing? No, we can't say like that. Okay. So charges are moving, number of charges are moving, then only we can able to say current is flowing. There are many charges, we can say many charges are flowing inside of the conductor. Many charges are flowing inside of the conductor, then we can say current is flowing. Yes or no? Now here, so positive charge, negative charge, like this I am taking positive charge, negative charge. Okay, so like that there are many charges flowing inside of the conductor, then only we can able to say current is flowing. Okay, yes. So charge is quantized. So Q Q equal to Ne. Sir, what is Ne? Sir, I have one doubt. So you are saying Ne. What is Ne? Ne is nothing but N is the number of charges. So E is an electron. So if you are taking electron, electron. If you are taking proton, proton. Okay, so it depends. So we just simply we can say charge. Okay, so charge is integral multiple, and one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb, and one electron 1.6 into 10 power minus 19 coulomb. Okay, so in 1 coulomb how many electrons are present? So that is one more question. In 1 coulomb how many electrons are present? So in 1 coulomb, if you are taking 1 coulomb 1 by 1.6 into 10 power minus 19, then you are doing 1 by 1.6 into 10 power 19, 10 power 19. If you do this, so in 1 coulomb, if you are considering, so 1 by 1.6, so 10 by 10, can we multiply, so into 10 power 19. Then if you do this, 1 coulomb, so 10 by 16 into 10 power 19, then if you do it again, 1 to 0.625 into 10 power 19, then 1 coulomb 6.25 into 10 power 18 electrons. So 10 power 18 electrons. So very important. These two values are very important. Okay, these two values are very important. On one electron, 1.6 into 10 power minus 19 coulomb, on 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb 6.25 into 10 power 18 electrons are present. So these two are very important. Make sure that you are preparing these 2 points. Okay, so next one, so we will discuss about electrical appliances. First we will discuss about electrical appliances, then we will go to the remaining. Okay, so related to this one, there is one question here. After writing this one, we need to write here. So 1 ampere equal to, that is nothing but I equal to Ne by T, So based on this formula also they will ask questions. Okay, so point number 1, I equal to Ne by 2. So based on this one they will ask questions. And Q equal to Ne, so we need to know this one. So we have to know this one. We should remember this one. We have to keep in mind this one. Okay, so whenever we remembering, okay, so whenever we are recollecting, okay, so these points are very important. Q equal to, charge is quantized, Q equal to Ne. Sometimes C value they won't give in the problem. So you must know that one. Okay, so you have to know this value, that is on 1 electron 1.6 into 10 power minus 19 coulomb. So you have to know this one, and this value also in 1 coulomb 6.25 into 10 power 18 electrons are present. Okay, these two values you should know. I hope it is very clear to you all, right? Okay, right? Yes, so very important points, very important point. This formula is very important. So this formula is very important, and this value is very important. This value and this value also, this value and this formula, and coming to this value also very important. MCQ's point of view very important. Make sure that you are preparing these two, or you are practicing. You should practice. Okay, then only you can get it right. Then next I will explain about electrical appliances. So here, okay, so I'll ask one questions. Related to this one. Name the SI unit of electric charge. What is SI unit of electric charge? SI unit of electric charge is coulomb. And define electric current and SI unit of electric current. Define electric current. The flow of charge. The flow of charge. So the flow of charge per unit time. Okay, or the rate of flow of charge. Simply we can say the rate of flow of charge. So that's enough. And related to this related to this concept, these questions are there. And one more question is there. They will give I value. Yes. The charge possessed by an electron 1.6 into 10 power minus 19 coulomb. Find the number of electrons that will flow per second to constitute a current of 1 ampere. Okay. So here charge possessed. So I will give the question. So just follow. So L on electron 1.6 into 10 power minus 19 coulomb and ampere current. So current is given 1 ampere and time is given t equal to 1 second. So we need to find out n value. How to find out? What is the formula we can use? These are the values. These are the values. Okay, how to find out? How to find out? What is the formula? Here you can observe the formula is I equal to Ne by T. So we can use this formula. I equal to Ne by T. So we can use this formula. By using this formula, you can substitute the values. I value is given. N value is given. Oh no, N we have to find out. So N we have to find out. Okay. So this N value we have to find out. E value anyway you know. So 1.6 into 10 power minus 19 and T value you know. So 1 second. So we can find out N equal to I into T by E. I into T by E. So by this one you can substitute all the values, you'll get it. Oh, thank you for suggestion. So I'll take it. Okay, done. Next one. I hope it is very clear. Electrical appliances will discuss. Electrical appliances will discuss. Electrical appliance. So there are so someone is asking Kirchhoff's law. There are two laws: junction law. Junction, sum of all the currents reaching to the junction is equal to, or the algebraic sum of current reaching to the junction is 0, or the sum of we can take potential in a loop you can consider. Okay, EMF and potential IR terms. If you are going a closed loop, the sum of all the potential in any closed loop is 0, right? So these two are there. Okay, anyway, we are discussing this concepts. So after these concepts, we'll discuss Kirchhoff's law. Okay, don't worry about it. Surely we'll discuss. Then come to the point. So first one is cell, positive terminal, negative terminal. Cell I am taking, and second one is battery, positive terminal, negative terminal. Battery. Coming to third one. So I am taking a switch. One is open switch. So open switch, and fourth one is closed switch. And fifth one is resistor, and coming to sixth one is rheostat. rheostat, either this one or rheostat, rheostat, rheostat. Coming to seventh one, ammeter, positive terminal, negative terminal. Coming to voltmeter. And next one, ninth one, wire joining. 10th one, wire crossing. 11th one is bulb. Galvanometer is a device which is used to test whether current is flowing or not, and also it shows the direction. At the same time, it measures small currents. This uh, small currents, very low current, it will measure also. Done. Next. So we'll discuss. These are the electrical appliances: cell, battery, open switch, closure switch, resistor, rheostat, ammeter, voltmeter, wire joining, wire crossing, and bulb. Okay. So here resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. So rheostat is a device. Rheostat is a device which is used to regulate the current without changing the voltage source. Rheostat is a device which is used to regulate the current without changing the voltage source. Coming to the ammeter, ammeter is a device which is used to measure the current. Ammeter is used to measure the electric current in the circuit. Voltmeter is used to measure the potential difference in the circuit. Potential difference in the circuit. Okay, I hope it is very clear. Wire joining, wire crossing, and bulb. Okay, so this is about electrical appliances. Electrical appliances. Now we will discuss about one more. That is true. Correct one. So it is also resistance. It is variable at the same time. So when resistance is varying, automatically current also changing, right? So R is inversely proportional to I. V equal to IR. Then now circuit, electric circuit, electric circuit, electric circuit. So current is flowing. So current I is flowing. Now you can observe here. Now we can observe. Okay, here 2 points are there. One is conventional current, another one is electric current. Conventional current and electric current. Conventional current, conventional current. Second one is electric current. electric current. So conventional current is nothing but the flow of positive charges. The flow of positive charges is known as conventional current. So the flow of positive charges is known as conventional current. The flow of electrons is known as electric current. The flow of positive charges is known as conventional current. The flow of electrons is known as electric current. So positive charges will move from high potential to low potential, high potential to low potential, whereas electrons will move from, so positive charges will move from high potential to low potential, whereas electrons will move from low potential to high potential, low potential to high potential. Yes, yes, right. Now here the direction of conventional current is taken in the order of, in the direction of flow of positive charges, flow of positive charges. So and the direction of electrons will be taken in the direction of electric current. That is nothing but flow of electrons will be taken from low potential to high potential. So there is one question related to this one. There is one question, that is, so will electrons flow from positive terminal to negative terminal, or negative terminal to positive terminal, or will electrons flow from high potential to low potential, or low potential to high potential, high potential to low electrons? Especially they will ask about electrons. Electrons will move from high potential to low potential, or low potential to high potential. So electrons will move from low potential to high potential. Electrons will move from low potential to high potential. So that is about conventional current and electric current. Conventional current and electric current. Next one we'll discuss one more. Electrical potential and potential difference. Next topic is electrical potential and potential difference. Electrical potential and potential difference. Electrical potential and potential difference. So are you all ready? Yes. Yes, we are ready always. Okay then, chalo, start, discuss. Now here you can observe potential difference. We'll discuss first. Potential difference. Potential difference. Potential difference is nothing but the work done to bring unit positive charge. Work done to bring unit positive charge. So I'm taking here. So this is the point A and point B. We are doing some work. We are bringing unit positive charge. Okay, so we are doing some work to bring unit positive charge from point A to point B within the field. Within the field. We are doing some work to bring unit positive charge from one point to another point within the conductor, within the field. Within the conductor, within the field is called potential difference. V equal to W by Q. V equal to W by Q. What is SI unit of potential difference? Volt. So 1 volt is 1 volt equal to 1 joule by 1 coulomb. 1 joule by 1 coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point. Once again, so I'm explaining the definition of 1 volt. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point is called 1 volt. Okay, so what is the potential difference? Work done to bring unit positive charge from one point to another point within the conductor. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, so that is about the potential difference. Coming to the electrical potential. Electrical potential. Electrical potential is nothing but electrical potential. So electrical potential, electrical potential, electrical potential, electrical potential is nothing but, so we are doing some work, so actually here this is the field, so I am taking this a positive charge, this is the infinity point, we are doing some work, to bring unit positive charge from infinity to the required field. So this is our required field. We are doing some work to bring unit positive charge from infinity to the required field is called electrical potential. So V equal to W by Q. Same V equal to W by Q we are considering, right? Yes. Now the electrical potential completed, potential difference is completed. So till now we discussed about electric current and quantization of charge, electrical appliances, electrical circuit, and conventional current and electric current. So potential difference and electrical potential. So after that we will discuss about Ohm's law. So related to this one, few questions we'll discuss. Okay, be ready with that. Ohm's law will discuss now. Ohm's law. So Ohm's law I am talking about Ohm's law. Now you can observe. Hi everyone, welcome to the student the brand. So here 1, 2, 3, 4. Ammeter. Oh, resistor. So here I am connecting voltmeter. Switch. Okay. So now you can observe here. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. So R equal to V by I. R equal to V by I. So this is very, very important. So Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. So materials required. What are the materials required for doing this experiment? Materials required. First of all, we have to take first one. We should consider 4 cells, 1.5 volts each. 1, 2, 3, 4. 4 cells I am taking here. 4 cells. 4 cells of 1.5 volts each. 1.5 volts of each cell. Okay. Second one we have to take nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And coming to the ammeter. Ammeter we have to take ammeter, and coming to the fourth one is voltmeter. Voltmeter. Okay, so voltmeter you have to consider voltmeter. Voltmeter. Voltmeter, and coming to fifth one is switch. Switch you have to take, and coming to sixth one is connecting wires. Connecting wires. Connecting wires. So what is the process? What is the procedure to do this experiment? Procedure is, first after you have to connect one cell. You have to connect one cell and note down the reading of ammeter and voltmeter. First procedure is connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter, and connect to two cells. Connect to two cells and note down the reading of ammeter and voltmeter, and connect 3 and 4 and repeat the same process 3 and 4. So I hope it is very clear, right? So repeat the process for 3 and 4 cells. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4 and note down the values of ammeter reading and voltmeter reading and mention in the tabular form given below. So this is the tabular form I am drawing. So first one, serial number of cells, ammeter reading, voltmeter reading, V by I form. Okay. Here. Now, so serial number I am taking, number of cells, ammeter reading, voltmeter reading, V by I equal to R constant, 1, 2, 3, 4. So we are taking 4 cells, so you can mention 4 cells. So we are taking 4 cells, that's why I am taking. So I am mentioning 4 cells. Now if you draw the graph for VI, V on y-axis, I on x-axis. So the graph is linear. Okay. So the graph is linear, a straight line are passing from the origin. Okay. So because V is directly proportional to V equal to IR. So this is for ohmic conductors. So ohmic conductor means the substances, the conductor which obey Ohm's law. The conductors which obey Ohm's law, those are called ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. Ohmic. And the conductor which does not obey Ohm's law, those are called non-ohmic conductors. So V on y-axis, I on x-axis. The graph is like this. Okay, so this is for non-ohmic conductors. Right? Non-ohmic. Okay, non-ohmic conductors. I hope it is very clear to all. So ohmic conductors and non-ohmic conductors. Yes? Right. Once again, so see the Ohm's law. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional. V equal to IR, R equal to V by I. Materials required. So 4 cells, 1, 2, 3, 4. 4 cells. So 4 cells of 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And ammeter, voltmeter, switch and connecting wires. First procedure. What is the procedure? First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells, note of the reading of ammeter and voltmeter, repeat the process for 3 and 4. Repeat the process for 3 and 4. So mention the values in the tabular form given below. Serial number, number of cells, ammeter reading, voltmeter reading, V by I equal to R. So 4 cells we connected. So that's why I mentioned 4. 1, 2, 3, 4. So and if you draw the graph for VI, the graph is linear for ohmic conductor, the graph is curved for non-ohmic conductors. Non-ohmic conductors. So I hope it is very clear to all. So this is about Ohm's law. Now we will discuss about resistance and resistivity. Actually, based on this one, few problems are there. Problems also we need to discuss. So 1 minute. Now we'll discuss about resistance and resistivity. Resistance and resistivity we'll discuss. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. Rho equal to RA by L. So I hope it is very clear. Just check once. So length is R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R equal to R is directly proportional to L by A. Rho equal to RA by L. RA by L. Okay. Now so SI unit of resistance is ohm, SI unit of area is meter square, SI unit of length is meter. So rho equal to ohm meter. Ohm meter. Clear? Yes. Now rho equal to ohm meter. Rho equal to ohm meter. This only ohm meter. Someone is asking. Unit of specific resistance. Specific resistance is nothing but resistivity only. Ohm meter. Okay. Now then differences we have to discuss. So differences we'll discuss now. So I hope it is very clear. So shall I write? Resistance is nothing but it opposes the electric current in the circuit. It opposes the electric current in an electric circuit. So resistance is nothing but R equal to rho into L by A. So here rho equal to RA by L. RA by L. Second one is SI unit of resistance is ohm. SI unit of resistance is ohm meter. Coming to third point is it depends on temperature. So third one here also it depends on temperature. Okay, fourth one it depends on material of the conductor. Now, so it depends on material of the conductor. Material of the conductor. Okay, so R equal to rho into L by A, rho equal to RA by L. So I hope it is very clear. And here one more thing. Resistance depends on length and area of the cross section. Depending factor depends. So here resistivity does not depend on length and area. Okay, so like we can say physical dimensions, it does not depend on length and area of the cross section. Okay, so this is about difference between resistance and resistivity. Now we will discuss about resistors are connected in series combination. Next, resistors are connected in parallel combination. We'll discuss now. So resistors are connected. Resistors are in series. Resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss. Resistors are connected in series combination. Resistors are connected in series combination. Next, resistors are connected in parallel combination. Now you can observe here. So 1, 2, 3. So 3 resistors, ammeter here. So battery, switch, positive terminal, negative terminal, current is flowing. So across R1, V1 I am connecting. So across R1, V1, this is V1. R1. Here is R1. R1, R2. So now here it is V2. So V3. and here is R3. So current is flowing. Okay, I current. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. V equal to IR. Right? Now, current is same in the circuit. Throughout the circuit, current is same. So that's why IS equal to I1 equal to I2 equal to I3. So I1 equal to I2 equal to I3 equal to. Okay, so current is same throughout the circuit. Current is same. Whatever the current is flowing in the circuit, throughout the circuit, current is same. But potential difference is different. Yes or no? So Girish BR, you wanted so badly answer for wearing this one, right? So just you can go visit the channel and check my channel, then only you'll get to know, right? Okay, done. So here current is same in the entire circuit. So current is same. So that's why now potential difference is different. So Vs equal to V1 plus V2 plus V3. Yes or no? Vs equal to V1 plus V2 plus V3. Now IRs equal to IR1 plus IR2 plus IR3. Shall I take I common because current is same, right? Wow. So nice question, Arjun. So the point is there is a pipe, water pipe. So 1 liter of water I am sending. Best example, there is a pipe. So the pipe is like this. So opposition is different, here is different, here is different, here is different. There is a pipe. So I am sending 1 liter of water. Imagine 1 liter of water I am sending. This is starting, this is the ending. Because so here some opposing, here some opposing, here are some opposing. There are many oppositions will be there. So whatever the 1 liter of water I sent through the pipe, so wherever it is, throughout the pipe, the water is same only, right? Throughout the pipe, water is same only, right? Water is not changing, right? Yes or no? So same principle will applicable here also. So whatever the current is flowing, even the opposition is there, same current is flowing. Yes or no? Same current is flowing throughout the circuit. I hope it is very clear to you all, and especially Arjun. Is it clear? Thank you. Thank you so much for confirming. So IRS equal to, I am taking common R1 plus R2 plus R3. So I get cancel. RS equal to R1 plus R2 plus R3. Okay, so RS equal to, if number of resistors are connected in series combination, number of resistor, RS equal to NR. RS equal to NR. RS equal to NR. Okay, if number of resistors are connected in series combination, so RS equal to NR. So current is same throughout the circuit. That's why IS equal to I1 equal to I2 equal to I3 equal to I. I am taking. So you can take I. Okay, so Vs equal to V1 plus V2 plus V3 because potential difference is different. So Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. So I am taking common, I get cancelled. Then RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So I hope it is very clear. If n number of resistors are connected in series combination, Rs equal to nr. Rs equal to nr. I hope it is very clear. Shall we go to the next one? Resistors are connected in parallel combination now. We will discuss about resistors are connected in parallel combination. Resistors are connected in parallel combination. Okay. Okay, now you can observe all resistors, all starting point of all resistors are connected to one point. So any point of all resistors are connected to another point. Then, so through R1, I1, through R2, I2, through R3, I3. So current is divided. Now potential difference is different. Potential difference is different. So potential difference is same. Potential difference is same throughout the all across all the resistors R1, R2, R3. Potential difference is same. Okay, but current is different. Potential difference across R1, R2, R3 is same, and current is different I1, I2, and I3. So I'll write like this. So VS no VP. VP equal to V1 equal to V2 equal to V3 equal to V. Okay na? Now current is different as I said. So V equal to IR, I equal to V by R. So IP equal to I1 plus I2 plus I3. Okay. So V by RP equal to V by RP equal to V by R1 plus V by R2 plus V by R3. So now I am taking V common, 1 by RP equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. Shall I cancel VB? So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So 1 by number of resistors are connected in C parallel combination. So RP equal to R by N. RP equal to R by N. I hope it is very clear, right? So once again, potential difference is same throughout R1, R2, R3. Current is different I1, I2, I3. Vp equal to V1 equal to V2 equal to V3 equal to V. So from Ohm's law, V equal to IR, I equal to V by I. So IP equal to I1 plus I2 plus I3. V by RP equal to V by R1 plus V by R2 plus V by R3. So 1 by RP equal to 1 by R1 plus 1 by R2, 1 by R3. So VV get cancelled. Remaining value is this one. Okay, done. So this is about resistors are connected in parallel combination. Resistors are connected in parallel combination. Now we will discuss about one more. Electric current completed. So resistors are connected in parallel, resistors are connected in series. Next, heating effect of electric current. Heating effects of electric current. Heating effect of electric current. V equal to W by Q. W equal to V into Q. So P is nothing but W by T. VQ by T. So P equal to V into Q by T is time. Sorry. that is current, Q by T is current, rate of flow of charge. So energy is given to the conductor, so E equal to P into T. So Vi into T. So we know V equal to IR. Yes or no? V equal to IR. H equal to IR into I into T. Then we'll get I square RT. So heat produced in the conductor is equal to I square RT. So this is about heat produced in the conductor. Okay, I hope it is very clear. So this is about heating effect of electric current. It is also known as Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. Okay, na? And potential of live wire is 220. Potential of neutral wire is 0. Potential difference between live wire and neutral wire is 220 volts. That's enough. And safety measures we are using in electrical, like especially in homes. In homes, we are using safety measures, fuse and fuse earthing. Okay, so what is use of fuse? Fuse is nothing but when extra current goes in the circuit, it melt and break the circuit. It is a safety measures which we are using in household. And one more thing, earthing. Extra current is there in metallic body that will send to the ground. So thank you so much for joining and attending, listening, commenting. Okay. So thank you so much for joining and listening and attending and commenting and listening my class. So this is our sir from Student the Brand. If you like the content, if you like the channel, if you like my explanation, please do like, share and subscribe to Student the Brand. Thank you so much. We'll see in the next class. Numericals will do in the next class, right? Thank you so much. We'll see. Bye bye.